folks, my name's Liam Grinton. I'm a potter here in Denver, Colorado, and I want to talk a little bit about a challenge that faces a lot of potters who are looking to build their own kiln. Fire bricks are very expensive, and they can add up to a considerable cost if you're trying to build your own kiln and you don't have a source of used fire brick from an old torn down kiln or from a boiler factory or something like that. I would say that if you can find used bricks, that's probably your best bet, no matter what. But if you don't have those available to you, I want to do a little experiment and see if I can make my own. Last year, I made some refractory bricks from hawthorn fire clay, sand, and hamster shavings to give them a little bit of an insulating characteristic, and that worked very well. But they were almost cost prohibitive due to the cost of the fire clay. They were still cheaper than buying new fire bricks, but still quite expensive. And so today I want to talk about an experiment to make that brick making process cheaper using locally available materials. I recently got in touch with a brick factory here in the Denver area and spoke with them about the materials that they use. And they said that they source materials from all around Colorado, some of them quite refractory and some of them not very refractory at all, but that they mix these materials together in order to create different colors and desirable characteristics in their bricks. I met with one of the folks at the factory, and they were kind enough to send me home with some 5-gallon buckets of the material that they use. And so right here I have an already ground shale that's a mid or high fire clay mineral. I would hesitate to call it really a clay because if you reach into it, the particle size is quite coarse even after being ground, and it doesn't fully slake down like clay would. But it does have some plasticity to it, certainly enough to make bricks. The other material that I came home with, this I was told matures at about cone 7. This material here is more of a stone than anything. This is a cone 34 extremely high refractory, basically silica-rich kaolinite, I was told. But the problem is that it's basically a stone. It doesn't slake down in water. This has been sitting for a couple weeks in water. It's a rock. It's a very soft rock. You can break it up, but this is not in any way plastic or usable for brick making. So today I want to try to grind down some of this material, maybe further grind down some of this material, and make some test bars that I can test fire and see what the characteristics, the shrinkage, the perhaps cracking that happens with some of these materials, and to see whether or not this will hold up a cone 10, because I think it may, or whether or not I need to add a significant amount of this to this in order to make this a high fire clay that will withstand repeated firing to cone 10 or higher for brick making. So I've decided to just take some of this ground shale, this stuff that's already been somewhat processed, and to just dry it out on the table here. I'll leave this to sit for some time. Maybe I'll move it outside on a wear board just to see if I can get this dry enough and plastic enough to make a test piece out of to test fire to cone 10 or to cone 11. So I'll move that outside in a little bit. And this I'm going to grind up using a very high-tech method of smashing it with a cinder block on the floor. That's my plan. I know that's not particularly graceful, but I think that will achieve an even grind and something that's perhaps plastic enough to work with. Now, as to how I'm going to do this when I build a kiln and I need to make 1,000+ bricks, obviously I can't crush all of that material using a cinder block on the floor. So I'll have to build some kind of hammer mill or large motorized mortar and pestle-like implement in order to do that. But I think that may be worth it. I've got a couple motors kicking around and I can probably jerry-rig something up. So let me get that all set up and then I'll check back in with you folks. So thanks for joining me here on the floor. I think this is going to be pretty low tech. I've got some of this refractory material here that I'm going to scoop out. Probably won't start with too much at once. And I guess this probably doesn't require too much explanation of what I'm about to do here. I'm just gonna do this. See if I can grind this down to a usable semi-plastic material by smashing. That's not unsuccessful. I'm just grabbing a scraper here to see if I can just kind of remove what's finished here. Put everything back together in the middle. We're just gonna I really only need just enough of this stuff to make a test towel to figure out the shrinkage. The firing cone, although this stuff fires quite high, I'm not sure that we're going to get there. Certainly, probably not. I think that's probably fine enough of a grind there to set aside. Get a little bit more in here. It is sticking to itself, so that's a good sign. Putting some weight on this. That's a little much, I think. And there's no doubt some impurities that are going to get into this material from doing it this way. I mean, the floor is not perfectly clean, and I'm sure there's some little bits coming off the cinder block as well. But, hey, I bet it'll be just fine. I think I'm going to go ahead and finish this up. I'll stop the camera. So after a couple minutes of intense grinding, this is what I have. This is, I mean, decently plastic for, you know, something that we're only going to be used to making bricks. This would, of course, not work at all as a clay body. But so I've got that. I'm going to wait for the other stuff outside to dry. And then I'm going to do 3 tests. 1, just this material. 1, just the cone 7 material. And then 1 test where these are mixed 50-50 together. I'll make shrinkage strips for them and we'll test them out. So the clay has since dried out enough. I've got the 2 super high fire clays here, and these are 2 equally sized balls of the cone 7 shale. And so I'm going to make 1 shrinkage bar out of this, 1 shrinkage bar out of this, and I'm going to wedge these 2 together and I'm going to make one that's a 50-50 mix of those two. So here are my shrinkage test bars. Here you can see I have a cone 7, I have the cone 34, and I have the cone 7 plus the cone 34, 50-50 each. I've put a straight line on each bar with a ruler, and I've made 2 endpoints on each line that are exactly 5 inches apart. And that means that when I fire this, I will be able to measure the distance between those 2 lines at the end and do a little bit of percentage math to figure out what the shrinkage rate is of the clay. And I will also be able to weigh these when they're fired in the end, and then soak them in water, and then weigh them again and be able to determine what the absorption is, and that'll be a good indicator of what the porosity and is of the clay and how much it is vitrified. So that's basically the process for testing these materials. This is really, really promising here in terms of its plasticity. This was horrific to work with. It's pretty much just pebbles glued together with a little bit of plastic material that's in there as well, but it's pretty hard to work with. It falls apart pretty easily. And this stuff is more than easy enough to work with to make bricks. So in a couple weeks, when these are dry and fired to cone 10, I will probably post an update on this. And yeah, wish me luck. See ya, folks.